Hello everyone, welcome to this new webinar from Zero to Mere Hero in 45 minutes. I'm Manuel, I'm here with Carlos.
Hello, how are you?
Carlos is going to help me with all the questions you have regarding this webinar. You can interrupt us in any moment you want and we will answer your questions, okay? Also, at the end of this webinar, we will leave some minutes for questions and answers. So let's start. Okay, so for those who don't know Plastic SCM, I'm going to explain the very basics of Plastic SCM in a few minutes. And I will start with the Branch Explorer. Okay, the Branch Explorer is our most important view in Plastic SCM. Here you can review all the branches, all the change sets, merged links, and labels in a single view. Okay, all the history of the project is represented in this diagram, and you can review all the progress of your branches and your project status. Okay, so let me zoom it. You can see here that we have several branches. For example, this first one is the main branch. We call it main branch, but you may know it as master or trunk. For example, in Subversion, okay, we call it main. And then we have several sub-branches. For example, this task 124 or this task 125. You can see that we have these little blue bubbles that we call them changesets. A changeset will contain a set of changesets, obviously, okay, and it represents every single check-in operation we perform in the Plastic SCM repository. We can use the changeset for multiple purposes. For example, we can review the differences of a changeset by double-clicking one changeset, and it will reveal us all the differences of the changes we perform in that certain changeset. Okay. Later on, we will see that we can create new branches or even label a changeset. Okay. So then, what we have here, it's also a set of links. You can review that we have this one, for example, that is a green one. It means that it's a merge link. It represents that this branch, for example, the task 124, is merged with the main branch, producing as the result this changeset with all the changes merged. We also have this gray link that represents the parent, which is the parent of one changeset, okay, and the child of one changeset. For example, this changeset is having this one as its parent, but this changeset is having two childs. So every single parent can have multiple childs, but one changeset can only have one parent. And finally, we have these green circles that represents the Plastic SCM labels. A label, it is related with a changeset in a relationship of one to multiple labels. Okay, one changeset can have multiple labels, but only one label can be targeting a changeset. So, for example, this latest label I have here, the BL that stands for baseline 134. It's labeling the changeset 109, okay? But I can create another label by right-clicking the changeset, and for example, let me create a 136, okay? And you can see that I can have multiple labels for the same changeset, but not in the other way. I can only have one changeset label with one label, okay? So let's move forward now with the commit operation that we call it check-in Plastic SCM. Okay, in order to perform changes in Plastic, you can follow the traditional workflow of checkout, edit, check-in. Okay, that consists in selecting one file that I'm going to be modifying, right-click it, and select checkout. I can also use the keyboard accelerator, Ctrl+O, but I'm going to be performing the operation by selecting the operation in the context menu. So now the file is checked out. As you can see, the icon is different. Now it represents that it is checked out in my workspace. Okay. Now I can edit this file. So for example, I can modify one line. So let's say that I remove this exit and I say goodbye. I save the file. I close it. And if I now go to the pending changes view, I will have the file listed as pending to be checked into the repository. I can also show the differences that I have just performed, okay, and review them in the embedded div view. Okay, so finally, if I'm happy with my changes, I can write a small comment and check in the changes into the repository. Every time I check in, I will get a new change set created. Now I'm working in the main branch, okay, so that's why I'm generating this new change set, okay. You can review that the comment is the one I have just typed, and the differences of this change set is just the change I perform. So every time I check in, I generate a new change set in the repository. Okay, this is the checkout, edit, check-in workflow, the most traditional one. But Plastic has another workflow that we call it Transparent SCM. The Transparent SCM is a very powerful system that allows you to work without telling Plastic that you are going to be modifying the files or moving them or removing or even adding new files to the workspace, okay? So I'm going to show you how it works. So for example, I can open this Codice CMD runner file, okay? And I can, let's say that I move a file. So for example, this is Windows method. I will move it from this line to the bottom of the file, for example. Okay, notice that I'm not checking the file out. Okay, I'm just modifying the file without telling Plastic a thing. So now if I go to the pending changes view and I refresh it, Plastic is going to search for change items. So it's finding us this item that has been changed. This method is not longer in this line, the 128. It is now at the bottom of the file. Okay, you can navigate through the move code by clicking in this button. Plastic knows that this is a fragment of code that has been moved. Okay, and it's able to match one fragment from the old revision with the fragment in the new revision. Okay, so this is what we call Transparent SCM, but the most powerful feature of the Transparent SCM is that Plastic is able to track the renamed items. So for example, if I rename this file, I remove the codice from the name of the file, I will I have another CMD runner here. So for example, let me remove to a starter CMD runner. Okay, now if I go to the pending changes view and I refresh it, you will see that I have a move item, but also is changed. So Plastic is able to track not only the change item, but also the move operation. The file is not longer named as Codice CMD runner, now is a starter CMD runner. Okay, this also works, of course, if instead of renaming the file, if I move it to a different location. Okay, look that if I refresh the pending changes view, it is still tracking the move operation. plus the rename operation plus the change operation. So now the file is not longer under CMD runner, now it's under CMD runner properties with the name change and the content also change. Okay, so this also works for some. Well, first of all, let me check in this change. This is a small refactor, and check in. Oh, sorry, I have to select the file I want to check in, and now I will be able to do that. Now, once again, I have a new change set, and my file is under properties. So this, of course, it also works if I remove a file. For example, if I remove this CMD runner csproc file, okay, and I go to the pending changes view, Plastic will be able to track this item as removed. This is very powerful because it allows you to work with Plastic even if Plastic doesn't provide a plugin for your favorite IDE. So, for example, if you are using Eclipse or NetBeans, for example, for NetBeans we don't have any plugin. So, that if you work with NetBeans and you perform every single change in NetBeans, you can later go to Plastic, search for the changes, and commit all the refactors and all your change code. Okay, so let me undo the change. I don't want to commit it, and I will continue explaining a very easy merge scenario, the very basic one, where I will be creating a branch, modifying some items, and then finally merging the changes back into main. So how do you create a branch in Plastic SCM? It is actually very easy. First of all, you need to select the base of the branch. If you click in a branch and you select Create Child Branch, Plastic by default is going to be creating the branch from the latest change set on your branch. That is this 111. Okay, but I don't want to start my branch from the latest change set. Okay, I rather prefer to start my branch from a well-known point, such as a label. Okay, so I guess because the label represents that everything is working fine, so I prefer to start the new branch from this label, for example. So I select Create Branch from this label, and I will give it a name. Okay, you can also select a change set and create the new branch from a change set. This is going to be exactly the same in this case. If I select instead of the label, if I select the change set, it's going to be exactly the same thing. Okay, so for example, the task 130. Okay, and now I want to switch my workspace after creating this new branch. I want to switch my workspace to this new branch. So I click OK, and you will notice that this house icon I have here that represents where I'm working on will switch from this branch, the main branch, to the child branch I'm going to create right now. So now my house icon is not longer in main, it's here. It represents that I'm working completely isolated from main. Every single change that I'm going to be creating now is going to be stored in this child branch. Okay, so let's go and let's modify a file. So for example, let's open the platform identifier file, and let's say that I want to remove this comparison. So if is Windows, do whatever. Okay. Oh, I think I have to remove the read-only attribute. You can work with read-only attributes or not. It seems that this file is having the read-only attribute. That's why I cannot save it directly. So let me check out. That will remove that attribute, and let's save it. Now I'm able to save it, and let's commit the change. By the way, if you are using the transparent SCM, it's recommended that you remove the read-only attribute from the Plastic SCM preferences. Okay, it is removed by default, in this workspace I have it enabled just for demo purposes. So let's go to the pending changes view and let's say if statement change. Okay, so let's commit, and now I have my new change set in the branch. I need to merge this change set with the main branch. To do that, I need to perform the following. First, I need to switch my workspace to the destination branch, which is going to be main in this case. So I switch my workspace to this branch. You will see that the house icon will change again. Now I'm in the main branch. Okay. Notice that if I open the platform identifier file, this if statement is having this comparison. Okay, so I'm back in the main branch, and now if I want to merge from this other child branch, I just need to right-click the branch, select merge from this branch, and Plastic is going to find all the merge candidates I have. Okay, in this case I only have one file, and of course this is the file I have just changed. If you don't understand why it's appearing this candidate, you can also always use this explain merge button here, and we'll explain to you the merge process. Okay, so in Plastic SCM, all the merge are a three-way merge operation. That means that we always have a destination, a source, and a base contributor. Okay, the destination is where I'm working. Okay, my working copy. The source contributor is the changes that are coming into my destination branch, and finally the base is the common ancestor between the destination and the source. That means that it's the change set that connects the destination and the source, the first one. Okay, in this case is this change set. So if I now process all the merge, okay, I will see that the merge is completely automatic, okay, because the main branch is not having changes in the platform identifier file, okay. So in order to accomplish completely the merge operation, I need to commit to check in the changes into the repository. I have them in my workspace, but I need to check in into the repository. So this is a merge done from task 130. Okay, so now if I check in, I can see in my branch explorer that I have a new change set and also a merge link that connects my task branch with the destination branch. It means that these changes are now also here. Okay, if I double click it, I can see that I have this change that is coming from a merge, okay, from the change at 112 from the 130 branch, and the change is this single line. Okay, so finally, let me label this. Okay, imagine that I'm running my test and everything is fine, everything is on green. So I can label this change set. So this is going to be the BL137. Sorry. Okay, you can rename a label if you make a mistake, as I did here. Okay, you can rename it, and it's going to be 37. Okay, perfect. So now that I have my label, I can continue creating new branches from the latest label. Okay, so this is actually what we call the task per branch methodology. Okay, or the branch per task methodology, sorry. That means that every time I need to create or develop a new task, I will create a new branch to develop it, okay, to store all the changes. So now I'm going to show you a more advanced merge operation, and you will see that the merge system of Plastic SCM is very powerful. I'm going to be creating two branches for this sample. It's going to be the task 138. Okay, I'm not going to be switching now, so I deselect that option, and I'm going to create another one. It's going to be the task 139. okay? And I'm going to be modifying the same file in both branches, okay? But not only modifying, I'm going to be moving that file in one branch. I will be moving that file to one location, and in the other branch I will move the same file into another location, okay? And we will see how Plastic handle those cases. So let me switch to this 138 branch, and what I want to do is I want to move, for example, this starter CMD runner from properties to back into CMD runner, okay, as it was before. So let me move it. I'm using the accelerator Control plus X and Control plus V, okay, to move one file to one directory to another, from one directory to another. But you can also use the context menu, or as I did before, moving the file using the Windows Explorer if you want, okay? So now that I have the starter CMD runner, I want to modify it. So for example, this default spin time, I'm going to modify the 45 value. Now it's going to be 10. And this mass wait time is not going to be 8, it's going to be 5. Okay, that's all. Let me save it, close the editor, and commit the change. This is going to be a change item plus moveth. Let me check in the file. Oh, I forgot to refresh the view, so I'm still having the change item. I only committed the move operation, so this is going to be change item. And now I have both of them. So now my branch explorer will show two changesets for this branch, one with the move operation and the other with the change operation. If I double click the branch, instead of the two changesets, I will have the two differences at the same time. One change and the same file move, okay? So now let me switch to the other branch. I'm simulating two developers working each one on each branch. And here what I want to do is the following. I have my file back into properties because the base change set of the branch is having a starter CMD runner under properties. So what I want to do is move this starter CMD runner from properties to the root item of my workspace. I'm going to be doing it with the context menu so you can see how I do the cut operation and the paste operation. It's exactly the same as using the accelerator Control plus X and Control plus V. So I'm going to modify the file once again. I'm going to force a conflict because I'm going to be modifying the same line, okay? This 8 number, this value, was changed into 5 in the other branch. Here I'm going to modify the 8 by a 1, okay? I save the file and I close it. In the pending changes view, I will have the two changes, okay, the change item and the move item. So this is going to be developer B changes. And let's check in it into the branch. Okay, so now I can start merging the task into the main line. To do that, as I did before, I switch my workspace to the destination branch and I start merging branches. For example, let's start with this one. This is going to be, as you may notice, it will be completely automatic because there's nothing in the main branch that can cause a conflict, okay? All the merge is going to be automatic. We will review it just here in the merge remarks. It says that the changes are only present in source contributor. Okay, it means that it's completely automatic. We may have conflicts later because we both modify the same file at the same time, and we also change the directory in both branches. So, well, let's process this merge. As you can see, it's completely automatic, and this is going to be the merge from the task 138. Okay, we can review the result in the branch explorer. I can see that this branch is finished, is merged into the main line. I'm still missing this branch to be merged into main. Just the same process, I right-click it and select merge from this branch. But now you can see that I have two conflicts. The first one is a directory conflict, and the second one is a file conflict. Okay, what does it mean? I can see that Plastic is telling me that I have a divergent move conflict. Okay, if I choose a resolution method, Plastic will explain to me what's going on. Okay, so Plastic says that I move one developer, the one in the source branch, move the starter CMD runner file from properties to the root item. And in destination, I have this same file. Instead of in the root item, I have it in the CMD runner directory. So obviously I need to choose one or the other because I cannot have the same file in multiple locations. Okay, so here Plastic allows me to choose a resolution. I can keep the move done on source and discard the other move operation, or I can do just the opposite operation. I can keep the move done on destination. So for this example, I want to keep the change on destination because having this file on the root directory, it doesn't make sense. I prefer to have it under CMD runner. To do that, I need to preserve destination. So I select this option, keep the move done on destination, and I click OK. So once the directory conflicts are done, I need to continue merging this file because I also changed the content inside this file. So now I can click process this merge, and you can see that I have the merge tool window appearing. Okay, this is a three-way merge tool. The contributor in the middle is the base contributor. Then on the left side I have the source contributor. Remember that I changed this number, only the one. And finally, on the right side, I have the destination. So, finally, sorry, and at the bottom, I have the result. Here, I can choose what I want to keep or what I want to discard. So, in this sample, I want to discard the base, okay, and also I want to, for example, let's discard also the source. You can even edit the result in this line. Okay, so if I don't want the 5 number here, I can switch it to 6 and save and exit the merge conflict. Okay, now as before, I need to go to the pending changes view and commit or check in the changes into the Plastic SCM repository. This is going to be merge done from task 139. Check-in. Finally, I can check in the changes into my main branch. Okay, as you can see, I have the two branches already merged into main. Now it's time to run all the test suites I have, and if everything is fine, I can label this latest changeset as my latest stable release. In this case, it's the baseline 138, sorry. If I click OK, now I have the changeset label, and I can start creating more and more branches. Okay, and this is the last example I want to show you regarding the merge system. This is one interesting merge scenario because Plastic is able to handle it perfectly. There are other systems out there that they are not able to handle this scenario in a good way, and you can see that it's very easy to understand what is going on and what do you want to keep in the merged result. And well, we think that the Plastic SCM merge system and the branches system is one of the best out there. So now it's your turn. If you have any question, this is when you need to write your questions. Raise your hand. We will be happy to answer all your questions. And of course, if you don't have questions right now, and then you start having questions later, you can write us using the Plastic SCM public forum, and we will be very happy to answer them.
Manu, I think Mohammed is raising his hand.
Okay. So let's review the question.
Mohammed, can you hear us? Mohammed, can you hear us?
Yes, I can hear you. Probably I came late to the lecture, the webinar. So my question is, why would we need two labels?
Okay. So there are some times where you need to have multiple labels. Okay, for example, when you need to deliver the same release for example, for multiple customers. Okay, you can have a naming rules for the labels for each customer. Okay, so for example, if if I'm delivering this release to Microsoft, okay, so I can call it Microsoft version 2.3, okay, and if I need to deliver the same changeset to another customer, okay, so for example Qualcomm, okay, I can label it to Qualcomm wherever, okay, so that's for example one scenario, having two labels for the same changeset. But of course in your daily basis you can find more utilities about having two labels for the same changeset. Of course the most usual scenario is having only one label for each changeset, okay? But the system allows you perfectly to have multiple.
Perfect. Wonderful.
Okay, if you have more questions, please. If you have more questions.
No.
Okay, so we are going to wait one more minute in order to see if more people is having questions. If not, we are happy to end now. Okay. As I said before, you can also contact us on our public forum, which is plasticscm.net, and also our Twitter account, which is @plasticscm. And finally, the support email, which is support@codicesoftware.com. So it seems that there are no more questions. So we are finishing the webinar right now. We will be very happy to see you on the next webinar. Thank you for your time attending this webinar. Goodbye.
Bye-bye.